Hello class. Till last session we had learned about division algorithm. So we can continue from division algorithm. Today we can complete exercise 2.3, exercise 2.4. That optional exercise it is very important. Now we can once go through what is division algorithm. We can have a summary of what is division algorithm. Division algorithm is P of x, which is equal to G of x into Q of x plus R of x. This is only division algorithm. So if you see P of x, what is P of x over here? P of x is the divisor. This is P of x. Wait. So this is the divisor. G of x is dividend. R of x is the remainder. Q of x is the quotient. Okay. So from this, always you must use Bodmas method for solving such problems. What some people do is some people make mistake by adding Q of x and R of x first. That is wrong. Okay. First, always you must use Bodmas method. Sorry, wait. So always you must use the Bodmas method. That is, whenever you get a problem, first you must divide. Then you should multiply. Then you should add. Then you should subtract. So accordingly, here also you should first multiply. Then you must add the remainder with it. So this is some common mistake which many people make. You should take care of that. Then now we can move on to the example problems in your textbook. So this is example 6 of page number 33 in your NCERT textbook. The question is, it's very simple. Divide 2x square plus 3x plus 1. Divide 2x square plus 3x plus 1 by x plus 2. Okay, you had already learned this kind of problems in class 8 and 9, but still for once recalling such problems, we can solve it. And I will tell how to complete this problem. That is very important in this problem. So now how will you proceed? So first, the main aim of solving such problems is cancelling 2x square. So you multiply x plus 2 with 2x. Why you are multiplying with 2x? So that it gets cancelled 2x square. So when you multiply 2x with x plus 2, when you multiply 2x with x plus 2, you get 2x square plus 4x. So now in division, when you multiply, and now it changes into subtraction. That is, plus sign changes to minus, and again plus sign changes to minus. Now this both gets cancelled, and 3x minus 4x is minus x, and plus 1 comes here. Now, the next aim is to cancel minus x. So what you should do? You should multiply x plus 2 with minus 1. So it will be, when you multiply x plus 2 with minus 1, it will be minus x and minus 2. So minus changes to plus and minus changes to plus. Right. Now here, this both gets cancelled, and plus 1 plus 2 will become 3. Now over here, this is P of x. This is P of x. This is Q of x. This is R of x. Okay. So now observe this problem carefully. This is P of x. This is P of x. This is Q of x. This is G of x. And this is R of x. So now, whenever you complete this problem, you write it in the form of division algorithm. So now in such problem, you must complete the sum by writing it in the form of this division algorithm. So this is the division algorithm. You must always complete it writing in this form. Okay, and this dot symbol in between, this represents multiplication symbol. In dot symbol represents multiplication. So now we will write that problem in this division algorithm form. So what is p of x over there in that sum? It is 2x square plus 3x plus 1, which is equal to, what is g of x in that problem? X plus 2 is the g of x. And what is q of x? 2x minus 1 is q of x. And what is r of x? Plus 3. So we have written it in the very same form. See, we have written plus and plus over here. So we have written it in the very same form. That is in the division algorithm form. So always complete such problem, writing it in the form of dividend, which is equal to divisor into quotient plus remainder. So now we will move on to the next example, example 7. So example 7 is going to be your homework. You can do it by yourself. It's very same mean. You always complete it in the form of division algorithm. You always complete it in the form of division algorithm. So now we can solve the example 8 in your page number 34 in your NCERT textbook. So in this problem, the P of X is given. The same thing you're going to divide and you to verify the division algorithm. So verification we will see in this question. So while doing this division, P of X is given like 3x square minus x cube. Okay, minus x cube minus 3x plus 5. And here G of X is x minus 1 minus x square. When you observe these both the P of X and G of X, here 3x square is in front and x cube is after 3x square. So here you can see that x square is before x cube. It's irregular than our usual problem. Similarly, in G of X, x square is at last. So what you should do in this problem, you should not proceed it like how we do in other questions. So just like that, you can't divide P of X by G of X. So what you should do is rearrange. You should rearrange P of X and G of X. So you should rearrange in the form of such that it starts with its degree. The degree is the highest. Now, degree is the what is degree? Degree is power of x in a polynomial P of X. So always you start with that and you go in the descending order. That is from bigger power to smaller power. So now we can rearrange this. So now let's rearrange. Now the new P of X will be P of X is equal to, first, what is the highest power? What is the degree of P of X? It's 3. It's a cubic polynomial. Therefore, first you start with the highest degree minus x cube. Then what is the next highest? What I had said, you should go with the descending order. Descending order. Okay, you must go with the descending order. So what is next? It is 2. So it comes over here plus 3x square. Then it is obviously minus 3x and 5. Always constant comes in last. Always constant comes in last. 5 is a constant of the polynomial. Of this polynomial, 5 is the constant. So this is the rearranged P of X. What I have written in green is the rearranged P of X. This is rearranged P of X. Now we should rearrange G of X. So now we can rearrange the G of X over here. X square is at last. So this is the degree. 2 is the degree of this G of X. It is a quadratic polynomial because the highest power in this polynomial is 2. So you always start with the highest degree. So we are going to rearrange g of x. G of x. So when you rearrange, first this comes over here, minus x square. Then what comes? X or minus 1? Which one comes? I had always said constant will come at last. What is the constant of g of x? It is minus 1. So x comes next, plus x, and at last the constant comes minus 1. So this is the rearranged g of x. So it is rearranged in such a way that it starts with its highest degree and it continues in its descending order. So when you are trying to solve a problem, first check whether it is in this such a format that it starts with its highest degree and goes in its descending order. Okay? Or otherwise, if it is not like that, you rearrange and then you proceed. So after this, we can divide as we did in example 6. You can divide it in the very same way as we did it in example 6. Okay, you can divide g of p of x by g of x. This rearranged form only you must divide. And then the question, next part of the question is you need to verify the division algorithm. Verify the division algorithm. So how will you verify it? So first, to verify it, what you should do is you write the division algorithm. Wait, I'm sorry. So you write the division algorithm. After writing the division algorithm, you take the p of x of that problem. Take the p of x. You know the p of x. So don't take p of x right now. You substitute g of x first. So what is the rearranged g of x? Minus x square plus x minus 1 into what is q of x? Q of x, that is the quotient after dividing this problem. It is x minus 2. And then what is the remainder? Plus 3. So now you should use your BODMAS method. You should use the BODMAS method. So according to BODMAS method, in this problem, multiplication comes first, then you can add. Okay. So now you multiply. First, we should do what we should do is multiply minus x square plus x minus 1 with x minus 2. Okay. When you do so, you get what after multiplication? You get minus x cube plus x square minus x plus 2x square minus 2x plus 2. So I believe you all know how to multiply such problems. First, you should take x and multiply with minus x square plus x minus 1 and then take minus 2 and multiply it by minus x square plus x minus 1. So you get this thing and the remainder at last. Now you can add the remainder because we have completed multiplying. So now you can add the remainder. Now we can add the remainder so that you get minus x cube plus 3x square minus 3x plus 5. Right? So x minus x cube minus x and minus 2x, it will become minus 3x. And x square plus 2, 9 plus x square plus 2x square, you will get 3x square. Right? You get 3x square and 2 plus 3 will lead you to 5. 2 plus 3 will lead. So this is the, so after multiplying, what you have got? After multiplying g of x into q of x plus r of x, you have done this. What you have got? You have got p of x. So now verify. So we have got this answer. And first of all, we have p of x, a rearranged p of x. What is that rearranged p of x we got during the time? It was minus x cube. So the rearranged p of x was minus x cube plus 3x square minus 3x plus 5. So now you see the rearranged p of x and this, the p of x that we have got is satisfied. As satisfied. So now what do you mean? What can you understand? Since it is verified. Now, so therefore, division algorithm is verified. You should complete the problem by writing. Therefore, the division algorithm is verified. So now I believe you are thorough with this. We can move on to example 9. So in this problem, we can see that, wait, first we'll move on to example 9. I'll write it in the board. So in this problem, the p of x that is given. So the dividend is given 2x to the power 4 minus 3x cube minus 3x square plus 6x minus 2. So for this, you can see that the degree of p of x is 4. The degree of this p of x is 4. Degree of p of x is 4. So what does that mean? The number of zeros for this polynomial is 4. So therefore, the number of zeros for this polynomial is 4. So for this problem, already there are two zeros given. They are saying that they have given 2 zeros. According to the question, 2 zeros are given. So 1 0, let's take it as alpha to be root 2 and beta to be minus root 2. Alpha to be root 2 and beta to be minus root 2. Because these two are the zeros given. So the question is, you need to find other 2 zeros. So we all know that this polynomial contains 4 zeros because the degree of this polynomial is 4. The degree of this polynomial is 4. So therefore we have 4 zeros. So you should find the rest of the 2 zeros. How will you find? So when you multiply this with another quadratic polynomial, you can get the other 2 zeros. So I'll show it how to do. You may be confused. So first, let's form a quadratic polynomial. How will you form a quadratic polynomial? So let's take the quadratic polynomial to be g of x. G of x is equal to x square minus alpha plus beta into x plus alpha beta. This we had already seen in the last session. So this is the new quadratic polynomial will be x square minus alpha plus beta into x plus alpha beta. So now we have alpha and beta, root 2 and minus root 2. So first let's find alpha plus beta. What is alpha plus beta? Alpha plus beta is root 2 minus root 2. Root 2 plus of minus root 2, which will become root 2 plus of minus root 2, which will become root 2 minus root 2, which is equal to 0. Okay, so therefore x square minus 0 of x plus what is alpha beta? Alpha into beta, that is equal to root 2 into minus root 2. What is root 2 into root 2? 2. And we have a minus symbol. Therefore, it is minus 2 plus of minus 2. Okay, now we have got x square minus x square. 0 into x will become 0. And we have got x square minus 2. So this is g of x. X square minus 2 is the g of x. Now let's divide p of x. So let's divide p of x by g of x. Okay, so that you get another quadratic polynomial. So in this case, you should know that we can solve quadratic polynomials. we can solve quadratic. We have methods to find zeros in the quadratic polynomial, but not in a cubic polynomial or any other polynomial. Therefore, we simplify this polynomial with a degree 4 to two polynomials with to two quadratic polynomials. Okay. So this is one quadratic polynomial. The g of x that we have got is one quadratic polynomial. This g of x is one quadratic polynomial. So let's divide p of x by g of x. So now let's divide p of x. So this is the p of x which we had already, this is given in the question. And this g of x was found when these two zeros were given. So this is a quadratic polynomial. Let's divide these both. So to cancel 2x to the power 4, you should multiply it by 2x square. So 2x to the power 4. Okay. Now minus 2x square. You have x square. You don't have x cube. You don't have x cube. Here it's cube, but it's square. When you multiply 2x square with 2, you will get only x square. So it's going to be plus 0x cube and 2x square into minus 2. Minus 4x square. Okay. It's going to be minus 4x square. So when you solve this, here you already have a plus symbol. Plus will change to minus, and again plus will change to minus. Minus will change to plus. So 2x power 4 gets cancelled. Minus 3x cube will be same because it's 0x cube. When you subtract it with 0, there will be no change. Therefore, it's going to be same. Minus 3x cube. Now when you solve minus 3x square plus 4x square, it is plus x square. And plus 6x comes down. Okay. And now we need to cancel minus 3x cube. So let's multiply x square with minus 3x minus 3x cube. And when we multiply minus 3x with minus 2, what do you get? Plus 6x, but again over here it is square. So it won't satisfy. You should put the respective degrees in its respective places. Therefore, minus 2 and minus 3x. When you multiply these two, you get 6x. But it's square over here. So let's put it over here because we should put it in the appropriate places, in the appropriate degrees. So now this also gets cancelled and this also gets cancelled because minus changes to plus. Minus 3x square plus 3x square is 0. 6x and minus 6x is 0. Now this comes down x square. And minus 2 is present over here. This also comes down. And when you multiply to cancel x square, you multiply it with 1. So x square minus 2, the remainder will be 0. This is the remainder. Okay, this also gets cancelled. This also gets cancelled because minus changes to plus. And plus is present over here. This will change to minus. So you'll get remainder 0. So now we have you have learned when two zeros are given, how to find the rest of the two zeros. No. Next, what you should do? Next step. The next step over here is we have the q of x. What you should do is take this q of x. What you should do is take this q of x and we are going to factorize this q of x. We should factorize this q of x. This is the q of x. And we should factorize this. We need to factorize so that you get the rest of the other two zeros. That is the question. What you need to find is, you need to find the rest of the zeros. Find all the zeros. But we know the number of zeros of this polynomial is 4 because the degree is 4. And now you can find, now we need to find the rest of the two zeros. So you take q of x and we need to factorize this. You take the q of x and factorize so that you get the other two zeros. So now when you multiply 2x square with 2x square minus 3x plus 1 with x square minus 2, you get 2x to the power 4 plus, minus 3x cube minus 3x square plus 6x minus 2. So this is the division algorithm. Now we have factorized 2x to the power 4 minus 3x cube minus 3x square plus 6x minus 2. Okay. So now let's find the other two zeros. For this, you should take the q of x. You need to take the q of x. So you need to factorize this. We have taken the 2x. So we have taken the q of x, that is 2x square minus 3x plus 1. So how will you factorize? You have 2 over here. You have 2 over here. So we need to factorize. What is the thing we need to do is you should take 2 because we have 2 in front. That is the coefficient of x square. So now you separate these two such a way that you get minus 3. So when you multiply minus 2 and minus 1, you get 2. And when you add when you add these two, we get minus 3x. So lead to minus 2x square minus 2x minus x plus 1. This is equal to, take 2x common, 2x common, 2x x minus 1 plus, not plus, here it will be minus y. Why it's minus? Because it is x minus 1 over here. This is x minus 1. Therefore, minus 1 into x minus 1. Now this will be 2x minus 1 and into x minus 1, x minus 1. So in order to find the zeros, you should equate it to 0. You should equate it to 0. So now let's take both the cases. 2x minus 1 is equal to 0 and x minus 1 is equal to 0. In this case, so now let's solve exercise 2.3. In exercise 2.3, all the questions in question number 1, you see question number 1, it is very similar to examples that we solved, and especially in third question, third subdivision, you should rearrange. Even in the second subdivision also, you should rearrange and then you need to solve. So it's going to be homework. Okay. So now in second question, what they're asking to do is, you need to check the first polynomial is a factor of the second polynomial. So second polynomial in those questions, you see the textbook now. In second polynomial, so the after the second polynomial given, that is after comma, second polynomial given is the p of x. So you should divide p of x. The first polynomial given is g of x. So you should divide p of x. You should divide p of x by g of x. Okay. And when doing so, like, see, when you divide p of x with g of x, you get a quotient, that is q of x. And in question there, what they're asking is, you need to find whether g of x is a factor of p of x. Okay. So to find whether it's a factor, when you multiply g of x, then you divide p of x by g of x, and at last, after completing the division, if you get the remainder as 0, that is r of x, if you get the remainder as 0 means, then it's a factor. P of x is a factor of g of x. So what do you mean by a factor? Factor means it completely divides. It is a factor. So g of x should be a factor of p of x means the remainder is 0. That means it completely factorizes this thing when you multiply p of x with g of x. So when you get r of x as 0, then p of x is a factor of g of x. So what do you need to do in this question? So in this question, what you need to do is you need to divide 2t to the power 4 plus 3t to the t cube minus 2t square minus 19 minus 12 with 2 square minus 3. So let's divide this. So it will be 2t square. So division is as usual. You should divide it. As usual, you can divide it and you get 2t to the power 4 and say it's 2. When you multiply 2t square with minus 3, you get minus 6t square. It's here, it's over its cube. So you should write in the respective place. Minus 6t square. Okay. And we can, now what you need to do is, it will be plus over here at first. Now change it, you will change it to minus. And it's minus over here, it will change to plus. And these both things will get cancelled. This will come down. 3t cube will come down. And minus 2t square plus 6t square is plus 4t square. And minus 90 will also come down. Okay. Now we need to get 3t cube eliminated. So what you should do? You should multiply t square minus 3 with 3t. So plus 3t. You get 3t cube. It's plus at first. 3t cube. And then 3t, when you multiply it by minus 3, you get minus 90. Minus 9t. So you should write it in the respective degrees, that is in its respective places. And you change the symbol. Plus will become minus and minus will become plus. Okay, these two will get cancelled. And over here also, it's getting cancelled. Minus 90 plus 90 is getting cancelled. And plus 40 comes down. 4t. And minus 12 is also coming down. Minus 12. Now, sorry, 4t square. Now you multiply. What the next thing we need to do? We need to eliminate 4t square. So you multiply this with 4 plus 4. It will become 4t square and minus 12. 4 into minus 3 minus 12. The remainder is 0. The remainder is 0. If you observe in this problem, so in this problem, the remainder is equal to 0. Since the remainder is 0, since the remainder is 0, 2t to the power 4 plus 3t cube minus 2t square minus 90 minus 12 is a factor of t square minus 3. So p of x in this problem, p of x is a factor of g of x. Okay. So in exercise 2.3, third and third subdivision of the second question is a homework. You try solving both the questions. It's very simple. When you divide p of x with g of x, if you get the remainder as 0, then the second polynomial is a factor of the first polynomial. If you divide p of x and g of x, if you get remainder not equal to 0, then in this case, In this case, p of x, that is the second polynomial, is not a factor of g of x. That's it. You must complete the problem by writing. If you get remainder as 0, it is a factor of p of x is a factor of g of x. And if you get remainder not equal to 0, you must complete it writing as p of x is not a factor of g of x. So now we can move on to the next problem, third question. So now third question also you are going to do, and I'll tell you the idea. So this question is very similar to example 9. So two zeros are given and you need to find the other zeros of that polynomial. You need to find the other zeros. So the p of x over here is 3x to the power 4 plus 6x cubed minus 2x square minus 10x minus 5. Okay. Now two zeros, that is alpha. What is alpha over here? Alpha is root of 5 by 3. And beta is minus root of 5 by 3. You are going to solve this problem. I'll tell you the idea. Alpha is equal to root of 5 by 3 and beta is minus root of 5 by 3. We had already done such a problem. Okay, what you need to find? First step. So you try solving this problem. If you don't know, you see this idea. You pause this video and you try solving it. If you don't know the idea, just see the session and then you try solving it. So first what you need to do is find alpha plus beta. What is alpha plus beta? It is 0 in this case also because root 5 plus 3 and minus root 5 by 3 is 0. So then alpha into beta. What is alpha into beta? Alpha into beta is root 5 by 3 into minus root 5 by 3. That is minus 5 by 3. Okay. So the product is minus 5 by 3. The next step, what we should do? We should find the polynomial. We should create the polynomial. We should create a quadratic polynomial to find the other two zeros. To find all other zeros. Here also the degree is 4. Therefore, the maximum number of zeros for this polynomial is 4. And we already have two zeros. Therefore, we need to find the other two zeros. So we can form a quadratic polynomial using alpha plus beta and alpha into beta product. So now we will form the g of x. The question p of x is given. G of x we are finding. So how will you find the g of x? It's x square minus. It's always minus over here. Alpha plus beta into x plus alpha beta. Now you substitute x square minus what is alpha plus beta? 0 into x plus what is alpha beta? Minus 5 by 3. So we have found the polynomial. Now next step is x square. 0 into x will become 0 and plus of minus. Plus of minus is over here is minus, so x square minus 5 by 3. Okay. Now you should divide g of x. You should divide p of x by g of x. So while dividing, anyway we are going to find the 0. Therefore, you equate this also to 0. Then what happens is you take LCM. 3x square minus 5 by 3 is equal to 0, which will become 3x square minus 5. Okay. So therefore, this is g of x. So what you should do is already p of x is given. Divide p of x with the g of x. So what we have found, that is 3x square minus 5. Okay. 3x square minus 5, should divide it. And after that, and after dividing, you get a quotient. So after dividing p of x with g of x, you get a, you'll have a quotient. You'll have a quotient, q of x. So what you should do is, you need to, q of x will be a quadratic polynomial because we have divided the polynomial with degree 4 by a quadratic polynomial. Therefore, q of x will also be a quadratic polynomial. Okay, because the quadratic polynomial into quadratic polynomial will give you a polynomial with degree 4. So q of x, p of x, when you divide it by g of x, you get q of x. And you factorize. And after factorizing, you equate it to 0. After factorizing, you equate it to 0 and you find the x values. Find the values of x. You will get two values. You will get two values for x, and those two values of x are the other two zeros. Those are the other two zeros. So at last, in question, they're asking to obtain all other zeros. It's not all zeros, it's all other zeros. All other zeros. Therefore, all other zeros, you will write it as, therefore, the zeros of x cube minus 3x square plus x plus 2. Sorry, I'm sorry. It is 3 to all the other zeros of 3x to the power 4 plus x plus 6x cube minus 2x square minus 10x minus 5 are those two values of x. So these two values of x are the other two zeros. So what you should do? You should divide p of x given in question. P of x is given in question, and this is g of x. This is g of x. We have found g of x. So the main thing in this problem is finding g of x. And after dividing, you get the q of x. And you factorize this q of x. You factorize this q of x, and you get, and then you equate it to 0. Then you equate it to 0, and you get two values. You get two values for x, and those two are the other zeros. Other zeros of the given polynomial. Fourth question, you can do it by yourself. What the thing is, you should use division algorithm. That is p of x, which is equal to g of x into q of x plus r of x. Now p of x is given, g of x you should find, q of x is given, and r of x is given. So you substitute. So this will be, after substitution, it will be x cube minus 3x square plus x plus 2, which is equal to g of x into q of x. So q of x is given. Sorry, q of x is given, right? What is q of x in this question? It is x minus 2 plus r of x is minus 2x plus 4. So now we can solve for g of x. First, what you should do is, you should subtract this, and then after subtracting, you divide it with x minus 2. What you should do is divide it with x minus 2, and then you get g of x. Solving. So for solving for one term, it's an equation. So it's like linear equation in one variable. Okay, so you need to find g of x. If any doubt, please post it in the group. So question number 5. This is an abnormal question. Okay, it's a very easy question. Only you need to give examples. So before that, you may need to know one concept, some small concept related to with degrees and division algorithm. One concept. Okay. So now This is an important note. Please note each and every point in this. If the remainder r of x is equal to 0, in first point they're telling that if r of x if this r of x is going to be equal to 0, if r of x is going to be equal to 0, then this g of x will is a factor of this p of x. So then when you divide p of x with d by d of x, and then if you get the remainder as 0, that is what we did in question number 2 and 2.3. Then what we get is, if we get remainder as 0, then the g of x is a factor of p of x. In second point, if r of x is greater than 0, okay? If r of x is greater than 0. So once again, I will repeat. If r of x is greater than 0, then if we take r of x to be a linear polynomial, then its degree is going to be 1, right? Similarly, if g of x is a quadratic polynomial, then degree is going to be 2. So 1 is obviously lesser than 2. That's what they're saying in the second statement. Okay? That if r of x is greater than 0, then degree of r of x is lesser than degree of g of x. Let's now understand the third note. Okay? Let's now understand the third note. Sorry, there is a typo. There's a typing error. That is degree of g of x plus degree of q of x is equal to degree of p of x. So this is p of x. So if it's the expression, there will be a degree. So let's take it to be a expression with degree 4. So let's take it to be expression with degree 4. We know that when we multiply a quadratic polynomial into another quadratic polynomial, you get a polynomial with degree 4. Okay, so similarly, let's take this example. What is the degree of a quadratic polynomial? It is 2. And this is also, sorry, it's addition. Degree, in degree, yeah, this is right. So what is the degree of the polynomial? It is 2. So when you add these two degrees, you get the degree of the polynomial, degree of p of x. So I had taken the degree of p of x to be 4. That is, when you multiply quadratic polynomial with a quadratic polynomial, you will get this p of x, right? So for example, when you had seen this third question and all, when you had got that g of x will also be a quadratic polynomial and q of x will also be a quadratic polynomial. So for both the quadratic polynomials, the degree is 2, and when you add 2, we will get 4. So which is verified, okay? So that's what third statement says. Degree of g of x plus degree of q of x is equal to degree of p of x. Take these three as notes. It will be very useful. You may not get it in your textbook. Okay. Now let's solve exercise 2.3. Exercise 2.3, fifth question. First subdivision. The condition is, so this is going to be v of x. Even in examination, suppose they ask this question, means you just draw this tabulation p of x, g of x, q of x, and this is going to be r of x. So first, the condition is degree. The degree means the highest power of x in the polynomial p of x, right? So that is the degree. Degree of this p of x. Degree of this p of x should be degree of p of x should be equal to degree of q of x. So you need to give such an example only. You should give an example. Normally they won't ask such questions, but you need to give there are many examples. So what the condition is? The condition is very simple. What is the condition is that for degree of this p of x and degree of q of x, it's the quotient. For degree of q of x to be equal, what you should do is you should know that both r of x and p of x are constants. You should know that these two are constants. What is constant? It is a normal number without any variable or coefficient. It is a number. Okay. So there are many examples, lots and lots of examples. Yeah, but for now, I will give my own example. So let's take p of x. Let's take p of x to be 2x square minus 2x plus 14. It must satisfy the division algorithm. Okay, if you take it in such a way, but you should know this concept, then you can find the examples, and you should make sure it is also satisfying the division algorithm. Then g of x is, since it should be a constant, this will satisfy. And then q of x is equal to, when you divide these two, you get x square minus x plus 7, and r of x is, and when you solve this, you get r of x as 0. So when you see here, the degree of p of x, this is p of x, degree of p of x is equal to degree of q of x. Therefore, condition satisfied. This is the condition given. Degree of p of x is equal to degree of q of x. Therefore, condition satisfied. Now the second one. So now the second condition is degree of q of x. Degree of q of x must be equal to degree of r of x. So if you refer to the notes, that's why I gave the notes. If you refer to the notes, that what they are saying is this degree and this degree must be equal. So if you refer to the notes, this is possible when degree of both q of x and r of x should be less than p of x and g of x. So this is only possible when, so this is the condition for this question. This is possible only when, so you refer to the notes, only when degree of the, so it's only possible when degree of q of x, so degree of q of x and degree of r of x, are lesser than the degree of p of x and degree of g of x. Okay, then this condition will satisfy. So my example, I'll give one example. So let's take p of x to be x square, x cube plus x square plus x plus 1. Don't forget, it must satisfy division algorithm. Okay. Now let's take g of x to be x square minus 1. So the condition is degree of q of x and degree of r of x must be equal. Okay. Degree of q of x and degree of r of x must be equal. Therefore, so the condition for this question is for these degrees to be equal, the degree of these two should be greater than those degrees of Q of x and R of x. So degree of P of x and G of x must be equal. So here Q of x will be x plus 1. So when you divide, you get P of x, you get Q of x to be x plus 1 and R of x is 2x plus 2. This is the example. Okay. You have many other examples. You can try different examples. Only condition is it must satisfy this, and another condition is satisfy division algorithm. Okay. Now we will move on to the third subdivision. Now the third condition is that degree of R of x must be equal to 0. So this is possible. So again you refer to the notes. Just try to figure it out from the notes. So this is possible when the product of Q of x and G of x. So this is Q of x and this is G of x. So when you multiply, so when the product of Q of x and G of x, when the product of this Q of x and G of x, this is possible only when the product of Q of x, I think it's messed up. I'll draw a new one. Okay. So only when the product of Q of x and G of x form a polynomial. So the product of these two form a polynomial whose degree is equal to the degree of P of x and constant term. So this you refer to note number 3. So you refer to note number 3. So that's what I showed. Quadratic polynomial into quadratic polynomial will give you a P of x with polynomial with degree 4. So we refer to the third note. So this is only possible. So degree of R of x will be possible only when the product of Q of x and G of x forms a polynomial whose degree of this will be equal to degree of P of x. Whose polynomial? So when you multiply these two, you will get a polynomial. When you multiply Q of x and G of x, you will get a polynomial. And if the degree of the new polynomial satisfies with the degree of P of x, then you will get a R of x that is equal to 0. Then you will get a R of x that is equal to, then R of x can be equal to 0. Okay. So now I'll give a example. So actually there are many examples. You can take one from already done. So you try this one. You try a new example using the conditions are satisfy division algorithm. Satisfy division algorithm. And another thing is what? That there's a condition. That is, it is possible only when the product of G of x and Q of x, then the new polynomial formed should match with the degree of P of x, then R of x will be equal to 0. Okay. So now let's solve the optional exercise 2.4. Exercise 2.4. Okay. So if you take this exercise, first question you can solve. That is, we had already learned for cubic polynomial, right? Alpha plus beta plus gamma is equal to minus b by a. Alpha beta plus beta gamma plus gamma alpha is equal to c by a. Alpha beta gamma is equal to minus b by a. If you have any doubts in solving this question, please refer to the previous session. Okay, we had already solved one such question. So you can solve both the questions from first. In the first question, you can solve both the subdivisions. Now we'll move on to the second question. So In this question, alpha plus beta plus gamma is given, that is equal to 2 alpha beta plus beta gamma plus gamma alpha is equal to minus 7 alpha beta gamma is equal to minus 14. Okay, these are the data given. You need to form a polynomial. So from this, you can understand that we should form a cubic polynomial. So similarly, we also have a form on how to form this cubic polynomial. So the cubic polynomial form is x cube. I'll write the formula x cube minus alpha plus beta plus gamma into x plus alpha beta, again a bracket, plus beta gamma plus gamma alpha into x, okay, minus alpha beta gamma. Okay, this is the equation. We should substitute. So we have the data. You substitute in this equation and you can get the answer. So the answer is, so the new polynomial that needs to be, so the cubic polynomial to be found is, answer is, this is the answer, x cube, okay, x cube minus alpha plus beta plus gamma is 2 into, here, sorry, I made it wrong, mistake in this equation. It is going to be x square. So please correct this. It's x square. Okay. This is x square minus 2 into x square plus, so it's given sum of its product of its zeros taken 2 at a time. So that is only minus 7 given. So let's take it as minus 7 into x minus alpha and beta into gamma as minus of minus 14. So when you solve this, you get, what you get is, so this is what you get after solving. So minus of minus will become plus at last. So this is the answer at last. Okay. So this is how. So this is the format for cubic polynomials. For quadratic polynomials, it is x square minus bracket of alpha plus beta, close bracket, x plus alpha beta. So for this, this is the format, and answer for this question is given below. So answer for this question is given over here. Answer is x cube minus 2x square minus 7x plus 14. Now we can solve the third question of this exercise. Third question of this exercise. So the zeros of the polynomial. Okay. So it's a cubic polynomial. Cubic polynomial means it has a degree. The given question has a cubic polynomial x cube minus 3x square. Wait. X cube minus 3x square plus x plus 1. Okay. So since you see here, you can now itself find how many zeros will this polynomial contain. So it is 3. So the number of zeros that polynomial contains is 3. So because the degree of this polynomial is 3. So now the format, what the zeros of this polynomial are in the form a minus b. So 0. So let's take, so we take all the 3 zeros to be alpha, beta, gamma. So now similarly, let's take alpha to be a minus b, beta to be a, and gamma to be a plus b. Okay. So what is required is you need to find a and b. So we know that in alpha plus beta plus gamma is equal to minus b by a according to the relationships with the coefficients. Okay, in last session we learned that alpha plus beta plus gamma is minus b by a. So let's do a similar thing over here. Let's add all these three. Alpha plus beta plus gamma, you get a minus b plus a plus b. So minus b and plus b gets cancelled, which you get 3a. 3a is equal to minus b by a. So what is minus b? You compare it with the general form and you get, so when you compare this equation in the general form, you get b to b, you will get b as, what is b? Minus 3, right? And a is 1. Okay. So now 3a is going to be equal to minus of minus 3. So 3a is equal to 3 and a equal to 1. Okay, a equal to 1. So we have found that a is 1. So now we also know that alpha into beta into gamma is equal to minus d by a. And when you compare it with the general form, you get d as 1 and a as also 1. So let's take the product of all these three things, a minus b. All these three terms, we can take the product into a plus b. So we know that a is 1. We had already found that a is equal to 1. So therefore, 1 minus b into 1 into 1 plus b, which is equal to 1 minus b into 1 plus b. So it's in the form a minus b into a plus b. Therefore, it's equal to a square minus b square. That is 1 square minus b square. So this is equal to minus d by a. So what is minus d by a? Minus of minus 1 by a. So it is going to be equal to minus 1 by 1, which is equal to minus 1. So 1 square minus b square is equal to minus 1. So 1 square minus b square, which is equal to minus 1. So then when you transpose it, you get 1 square. 1 square is 1, right? So let's take it to be 1. Let's take it to be 1. 1, and when you transpose this minus 1 this side, you get plus 1. And this will become b square. It's because you're transposing minus b square to that side. So 1 plus 1 is 2 is equal to b square. And b will be root 2 plus or minus root 2. Why plus or minus root 2? Minus root 2. Okay, we have found already, I'm going to rub the board, that's why I'm saying. A is equal to 1. Okay, we have found that a is equal to 1 and b is equal to plus or minus root 2. I'll explain why b is equal to plus or minus root 2. You may already know it. So b is equal to plus or minus root 2. Why plus or minus root 2? Because b square is equal to 2. Right. So when you take minus root 2 into minus root 2, then also you get 2 because minus of minus is plus. And root 2 into root 2 also you will get 2. So therefore, because of this only, we are taking b to be plus or minus root 2. Okay. So therefore, at last, how will you end the answer? So at last you must end the answer, right? So they are asking you to find a and b. So the values of a and b are a is equal to 1, b is equal to plus root 2 or minus root 2. This is the answer. So let's move on to the fourth question. We had already did this type of questions, that is 2 zeros will be given. Actually, when you observe this question, 2 zeros are given. So you need to find rest of the 2 zeros. So where two zeros are given? 2 plus or minus root 3. So 1 0. Alpha is 2 plus root 3. Beta is 2 minus root 3. Right? Because we tell this to be 2 plus root 3 or 2 minus root 3. Therefore, two zeros are given. So with these two zeros, we had already, I had told you alpha plus beta, alpha beta, find the quadratic polynomial, find the quadratic polynomial. Find the quadratic polynomial and then you divide the given p of x with this quadratic polynomial and then you will get a q of x when you divide. After dividing p of x by g of x, that is the quadratic polynomial that we have found using alpha plus beta and alpha beta. We know already, or please refer to the in this video the previous questions like question number 3 of 2.3. After doing all these, okay, q of x, and then what you need to do is factorize and then equate. After factorizing it, equate it to 0 and find the values of x. Find other values of x. So the other two values are the the other two values so the other two values are the zeros. So you factorize and you equate it to 0 and then the other two values of x are the zeros. So this is a very similar question. This you need to do as a homework. If you have any doubt, post it in the group. So fifth question is a very, very important question. The last question of this chapter. After this, the introduction parts are completed. I will send some new questions. You will get some new questions. After completing this chapter, you go through the summary once. Okay, now we'll solve the fifth problem, then I'll give you some instructions. Okay, fifth problem. So let's now solve the fifth question. It's a very important question. Listen very carefully, step by step. Okay, p of x is given. So what we'll be doing is dividing this term. Okay, I'll grab this file because we need a lot of space. X to the power 4 minus 6x cube plus 16x square minus 25x plus 10 plus 10. Okay, wait. Plus 10. If you can try solving this question. Definitely, you might make some mistake in some place. Okay, so if you had solved it, it's very good. If not, you see this answer solution which I'm giving you. So it's going to be x square minus 2x plus k. This is the question. So if you divide these two, okay, right? So when you divide these two, the remainder comes out to be in the form x plus a. Then you find k and a. Okay. So now let's first divide this p of x, that is x to the power 4 minus 6x cube plus 16x square minus 25x plus 10 with x square minus 2x plus k. So x square. Now what? When you multiply x square minus 2x plus k with x square, what will happen? So it will be x to the power 4. Okay, and x square, when you multiply it minus 2x, you get minus 2x cube and plus k x square. Just write it like this, plus k x square. And now you are going to change the signs. So it's already plus here. Now you're going to change it into minus, and it's going to change into plus, and plus is going to change into minus. So 6x to the power 4 and x to the power 4 gets cancelled. Minus 6x cube plus 2x cube. You will get minus 4x cube. You will get minus 4x cube. You will get minus 4x cube. Okay. And then what will happen? Plus 16x square minus kx square. So I can group this 16x square and minus kx square together, right? So I can group these two together. So what I'll do is I'll rub this and I'll write it as 16 minus k to the whole x square. And I'll bring this thing down, minus 25x. Okay. Now we'll move on to the next step. Now it's going to be minus 4x. Okay. And it'll be minus 4x cube. And it's plus 8x. Okay. This plus 8x square plus 8x square. Right. And then minus 4kx. Minus 4kx. Again, symbol changes, so it gets cancelled. Plus 16 minus 8. 16 minus 8 is 8. So it will be 8 minus k x square. It will be 8x square minus kx square. So when you group it, it will become 8 minus k whole x square. Okay. And now again minus 25x plus 4kx, and it will become minus, and while subtracting minus 25 plus 4kx. So when you group it, you get bracket of 25 minus 4k whole of x. And I'm bringing this thing plus 10 down, plus 10. Okay. So till this you get thorough. You try solving along with this tutor. You try solving this question. This is a very important question. So after grouping, I get 8 minus kx square minus 25 minus 4k of x plus 10. Okay, I'll rub this part because I'm not having enough space, and I'll get this thing up. Okay. So now, next thing what you need to do is you should cancel 8 minus kx square. So what I'll do, you just multiply the 8 minus k. 8 minus k multiply and 8 minus k the whole of x square. Okay. And then what will happen when you multiply? If you're having any doubt, okay, just multiply it aside. 8 minus k with minus 2x. So after multiplication, this is what you get. So you multiply these two, minus 2x into 8 minus k. What you'll get? So minus 2x into 8, you get minus 16x. and plus 10. So minus 16x plus kx. So you group this, you take minus out and you group it with x, you take x out and you get 16 minus 2k, right? You get 16 minus 2k because it's plus 2kx. I'm sorry, plus 2kx. So you get x minus x into 16 minus 2k. Okay. So now plus symbol is there and we get it into minus and this will become plus and this will become minus. So till now you try to understand each and everything. It will take some time. Try to understand each and everything. Now I'll rub the board. I'll get this thing up after solving. I'm gonna solve and I'll get the product over here. I'll get the answer over here. Okay, I'll get the product. I'll get the answer over here somewhere. I'll rub the board. So just you observe each and every step once by pausing the video. You pause the video, you observe each and everything, and then we'll move on. So while solving, this will get cancelled. Okay, and minus of 25 minus 4k and plus of 16 minus 2k. Right. So minus 25 plus 16 you need to do. So that is what solving will take place. You try solving by keeping a notebook. Okay. By keeping a notebook with you, try solving this. The simple addition and subtraction. So I'll get you the answer. I'll get you the reminder. After solving this, you're getting the reminder. That's it. So now after solving after adding and subtraction and additions and subtraction, you try it out in a notebook. After solving, you get minus 9. And then you group it. Okay, minus 9 plus 2k of x plus 10 minus 8k plus k square. So according to the question, remainder is in the form x plus a. Remainder is in the form. So according to the question, remainder is in the form x plus a. So what till here? This is x. So this is x and this is plus. This is going to be a. Okay. So now when you compare the coefficient, here the coefficient is 1 and here it is minus 9 plus 2k. Therefore, minus 9 plus 2k is equal to 1. And solving this, you get 2k is equal to 10 and k is equal to 5. You get k is equal to 5. Okay. So the part of the question is you need to find k and also you also need to find a. So this is only a. This is a, right? So now a is equal to 10 minus 8. We have already found k to be 5. So k is equal to 5 into 5 plus 5 square is 25. So this is a value. A is equal to 10 minus 40 plus 25. And you will get a to be minus 5. 10 minus 40 is minus 30 plus 25 is minus 5. Therefore, at last you will write as answer is k is equal to 5 and a is equal to minus 5. So I believe you understood this answer. It's very important. It's a very important question. Okay. If you have any doubt, please post it in the group. We have completed all the exercises of this chapter. You go through the summary and very soon I will send a worksheet in the group consisting of good problems. So you need to solve it and we will have a session for answers of that questions. Okay. And now we have completed the textbook. You go through the summary And if you have any doubts, post it in the group. And thank you.